Hello, Kumar. Good evening. So everybody has joined. So before starting the session, let me introduce myself. So this is Saket Verma. So I'm having more than 13-year teaching experience, and my qualification is MTech from IIT Guwahati in signal processing. Cracked the different PSU exams as well, and I have mentored more than lakhs of students and the arithmetic theory communication system. These are my area of expertise. So if I go into the option number next questions, like in the previous two classes, we have solved some new questions, and I was seeing that some of you were discussing in the Telegram group. So that's good to see that all of you are discussing on the Signal and System Telegram group, and you can get the result obviously when you discuss. So I will tell you the explanation also. There are some questions for which you are asking doubt. I will definitely tell after this session. And if I talk about the study with the Telegram group, so study with Saket Verma is the link for the Telegram group, and here you get the different type of updates and scholarship test every Sunday. And this Sunday also we have a scholarship test from 9 a.m. to 9 p.m. And today also there is a workshop, so you can join the workshop. So let's start with the first question of today's session. Try to solve this question. Yes. Hello, Vicky. Answer this question. You have to calculate the impulse response of the system. Last 44 seconds. See, you are getting. Yes, right answer is option number D. Right answer is option number D. Let me tell you how. So x of t minus 3 by 4, x of t minus 3 by 4 dy by dt. Okay, just reverse process. And then minus 1 by 8 yt equal to d2y upon dt square. This is what we are getting. Okay, x of t, this is x of t minus. So when you go this side, this is integration. So here you will get the differentiation. Here you will get the double differentiation. So this is your d2y upon d2 square. This is dy by dt, and then this is yt. So this y 1 by 8 yt, 1 by 8 yt you are subtracting because these two are going in the minus side. So this is, here we are getting dy by dt into 3 by 4 plus 1 by 8 yt. Now this is xt minus of this equal to d2y upon dt square, right? Hello, good evening, Shansh. Yes. So taking the Laplace transform now, taking the Laplace transform, we will get x of s equals y of s in bracket s square plus 3 by 4s plus 1 by 8. So the h of s, which is y of s divided by x of s, will become 1 upon s square plus 3 by 4s plus 1 upon 8. Right? Now we have to perform the partial fraction. This is a upon s plus 1 by 2 plus b upon s plus 1 by 4. Okay, now you can calculate the value. This minus 4 and 4 is coming, right? Minus 4 upon s plus 1 by 2 plus 4 upon s plus 1 by 4 is coming. Now taking the inverse Laplace, we will get minus 4 e to the power minus 1 by 2t plus 4 e to the power minus 1 by 4t. So if I take the 4 common, in fact the minus 4 common, then it is e to the power minus 0.5t and minus e to the power minus 0.25 into t. So this is your h of t. This is option D. Hello Akansha, Shayansh. Yes, correct? Now coming to the next question. Let's answer this question. Okay, so one option I have got answer as A. Yes, Akansha also got the answer A. Yes, perfect. 1 upon T. Good. Just 1.5 minutes more. I would like other students also to answer this question. Last 1 minute, quickly. The other students can also answer this question. Yes, A. So all of you got A, but the right answer is D. The right answer is D. Let's see how. This x of t is e to the power minus 3t minus e to the power minus 2t divided by t. So suppose I take this t xt this side, then it is e to the power minus 3t minus e to the power minus 2t. So if I take the minus sign also in the left hand side, then it will become e to the power minus 2t minus e to the power minus 3t. Taking the Laplace transform, this is s into differentiation in x dxs upon ds, right? And this is nothing but this 1 upon s plus 2 minus 1 upon s plus 3. Okay, now when you will differentiate it after taking this log, you will get, when you integrate it, you will get log s plus 2 and minus log s plus 3. Got it? Okay, minus t xt means the differentiation is the Laplace domain. So I am taking the Laplace transform both the side. I get this. Answer this question. Answer this question. Yes, Akansha, thank you. So one answer I got from the Kumar as 4. Let's see. Last 40 seconds. How many of you can give the correct answer for this? First option I have got as 4. Harihar Sudanan 3. Anyone having 2? Okay, so the right answer for this question is 0. The right answer is 0. Let's see how. First of all, you will write the signal x of t. This x of t is unit step signal having the amplitude 2. So it is 2 ut, right? Then there is a ramp at 2. So minus or plus ramp at 2. So rt minus 2 because the slope is 1. This line is having the slope 1. Now it is minus minus of r t minus 4 to cancel the slope, but there is a change in amplitude also, so minus ut minus 4. This is our original signal which is given, but they asked in the form x of t is equal to 2 ut, so 2 ut is there, so let substitute the rt is equal to tut, we know that. Okay, RT is equal to 2 ut. So x of t equal to 2 ut plus t minus 2 ut minus 2 and t minus 4 ut minus 4 minus 4 ut minus 4. Now let's solve it and get the, as per the question, t ut minus 2 minus 2 ut minus 2 minus t ut minus 4 minus 4 u minus 1 has become plus plus 4 ut minus 4 and minus 4 ut minus 4. So these two will get cancelled. Minus minus has become plus here also. This is plus tut minus 2 plus 4. No, no, okay, okay, this was correct. Minus 2 ut minus 2, then minus t ut minus 4. Okay, fine. Now what is our standard form? 2 ut t minus 2 ut minus 2. So t ut minus 2. Okay, fine. These two are correct. Now the last two term ut minus 4 we have to take common. So ut minus 4 you have to take common. Okay, so this is ut minus 4, and along with this t minus t naught is there. So this is 2 u t plus t minus 2 u t minus 2. There is no need to change exactly. Minus t minus 0 u t minus 4. And this term, these two term, we have already got these two term. And when we compare the last term, when you compare the last term, that value of t naught is 0. The value of t naught is 0. Okay, yes. Now answer this. So first option I have got as Harish Arsudan. Option number A is 1. So first answer as 1. Let's see whether it is correct or not. 53 seconds left. 50 seconds left. Pi. Now the second option is pi. Not solving. 2 pi. So now the right answer is 0.5. The right answer is 0.5 for this question. Okay, let's see how. X of t equal to, we can write pi in bracket sine t multiplied with sine t upon 2 whole divided by pi square t square, right? Now this is pi, we can separate it out and we can write sine t upon pi t multiplied with, okay, I think there is a, yes, there is a mistake in the question, I guess. T, no, it should be then. Okay, bye, fine. Sine t by 2. T by 2 upon pi t. They are multiplied in the which domain? They are multiplied in the time domain. So we can say that they will get convolved. So x of j omega. Yes, no, no. Actually, I thought there was a mistake in the sign and sync, but yes, because of that only you will not get pi. Okay, so this is nothing but a rectangular of omega by 2 convolved with a rectangular of omega, right? Yes, they are divided by 2 pi only, miss. Okay, so now you will have to convolve it. So there are two rectangular pulse which you have to convolve. One is having the width 1 and another is having the width 2, like this. Minus 1 to 1, and you can take any one of this as 1 by 2 and another is as 1, minus 0.5 to 0.5. Okay, now when you will convolve them, what you will get? Definitely a trapezium. So trapezium you will get, and the minimum value will be minus 1.5. This one will be minus 0.5. This one will be 0.5. This one will be 1.5. Okay, the slope will be 1 by 2. Slope should be 1 by 2. So this is 1. So the height should be 1 by 2. Okay, so at omega equal to 0, you will get 1 by 2. Sin t upon pi t is having the Fourier transform rectangular omega by 2. Right? Is it clear now? This is x of j omega. Okay, sampling of t is having the Fourier transform a sampling omega t by 2, t into capital T. Let me write in this form. If you want to write sync, just opposite a, a rectangular t upon t. Okay, in this form if you will write, then it has the Fourier transform at sampling omega t upon 2. Okay, and then you can write in this form at sampling t into capital T by 2 is equal to 2 pi a rectangular omega by t. Okay, Kansha? Now in this question we have sin t upon pi t, suppose, right? So sampling is nothing but a sin t into capital T by 2 divided by t into capital T by 2, and we have a t. So its Fourier transform will be 2 pi a rectangular omega by t. Now if you compare it, we have pi t. So that means capital T by 2 is equal to pi. Capital T by 2 is equal to, from the coefficient we have 1. Okay, so capital T by 2 is should be 1. So we have to multiply pi. So this pi you have to bring in the denominator. Okay, here capital T by 2 equal to 1 if I put, then the left hand side will become 2 into a, because the t is equal to 2. So sine of t divided by t, and 2 pi, this is a rectangular omega by 2. Okay, this 2a and this 2a will get cancelled. Now we will get sine t upon this pi also you bring in the denominator. Then it has the Fourier transform rectangular of omega by 2, which is what I have written here. Rectangular of omega by 2. Got it, Akansha and Kumar? Okay, now similarly, in the same way, compare it and write it for the second term. You will get this 1 by 2 extra. Then you will come to the answer. Okay. This relation I used. Okay, coming to the next question. Finally, finally, you are getting the right answer. Yes, Akansha and Hari, both of you have got the same answer. So I'm hoping that you guys are right this time. 12.56. Okay, last 1 minute. Anyone else who wants to answer? Hari, Kumar, and Akansha. Other than these three students, Rahul, and Vicky, Shreyansh. Yes, yes, definitely. You guys will do the calculation mistake only. I am sure that if you are preparing for GATE, that means you will be clear with all the concepts. Now there is a point that whether you apply the right concept at the right time. Second, the approach that you are applying for the question is correct or not. And the third one is the calculation. Only these three things will be important now when you are in this stage of preparation. So I'm sure that you guys are well prepared for exam, but these are the common mistakes that you do. That's why the practice are important. So e to the power minus at ut will have the Fourier transform 1 upon a plus j omega. Applying the duality property, 1 upon a plus jt will have this 2 pi. Okay, this 2 pi e to the power minus of a, t is replaced by minus omega, and t is replaced by minus omega. So here we have 1 upon 1, a instead of a we have 1, so 1 plus jt, and this is 2 pi e to the power minus, minus become plus, so plus omega and u of minus omega. But because there is a factor 2 also in the numerator, so 2 upon 1 plus jt is 4 pi e to the power omega u of minus omega. On comparing with the given question, the value of a is 4 pi, which is 12.56. Now answer this. So the right answer is 1. So here the transfer function of the filter, if you calculate, 1 upon k plus j omega. Okay, this is the response given. So now at omega equal to 0, you will get the maximum value, which is 1 upon k. And if I calculate the magnitude h of omega mod, then it is 1 upon root over k square plus omega square. So it is saying that at omega 3 dB, at omega is equal to 3 dB, it is having 1 upon 2 pi. The frequency at 3 dB point of the signal is 1 by 2 pi. So 3 dB frequency is 1 upon 2 pi. What is 3 dB frequency? So at 3 dB frequency, it is given in hertz. Na? So remember that it is given in hertz. So it is in omega domain, it will be 1. Okay, it is given in hertz. So it is 1 actually in radian. We should write in this way. F3 dB, F3 dB is 1 upon 2 pi. So omega 3 dB will be 1. Okay, and at 3 dB point, the amplitude will become 1 upon root 2 times. So this will become 1 upon root 2 times of k, and 1 upon root over k square plus 1, because the omega 3 dB is 1. So now when you square it, you will get k square by 2, 1 upon k square plus 1. So it is 2k square plus k square equal to 2. It is 1 upon k. Sorry, I thought what is happening, that k square is coming again and again. 1 upon k. So when I square it, we will get 1 upon 2k square. So it is k square is equal to 1. So k is equal to plus minus 1. But it is saying that k is always positive. So we will take the positive value of k. So our answer is k equal to 1. Now answer this question. Yes. So the right answer is C only. I mean this. C is the right answer, Kumar. Previously you said right, but I think you get confused. After some time you are changing your answer after giving the right answer. It is the right-handed signal, na? So in the right-hand signal, the pole ROC should be in the right side of the rightmost pole. The ROC should be right side of the rightmost pole. Yeah, so let's solve this. Yes, so two answers A, and the right answer is option A only, correct? So if I go through the solution, then h of n, this is 1 by 2 to the power n un, and minus of a 1 by 2 to the power n minus 1 un minus 1 equal to delta n. If I put n equal to 1, suppose, because I want to calculate the constant value, so 1 by 2 u1 minus a, it is 1 by 2 to the power 0 and u 0 delta 1. So this is 1 by 2 minus a equal to delta 1 is 0. So a equal to 1 by 2. Yes. So right answer is 1 by 2. Now answer this question. Inverse Laplace transform. Possible inverse Laplace transform means you have to look for the what are the possible ROCs, valid ROCs. No answers? See, number of inverse Laplace transform you can directly calculate by formula. Number of distinct real poles plus number of complex poles divided by 2 plus 1. So here the number of distinct pole is 1, and if whether it is real or complex, let's check. So minus b plus minus b square minus 4ac divided by 2a. So 2 plus minus 4 minus 40. So it is giving you the imaginary term. So minus, it is a plus 1, 1 plus minus j 3. So there are two complex poles. Number of distinct complex poles. Okay, number of obviously distinct complex poles. So there are two complex poles plus 1. So 2 divided by 2 is also 1. So 1 plus 1 plus 1, 3. So number of possible inverse Laplace transforms are 3. Got it? Is it clear? How to calculate number of distinct real poles, number of distinct complex poles, divide by 2 plus 1. Please note it down if you have not studied before. This is a good formula to calculate quickly. Now that this is a plus 1, the derivation part I am not telling why this derivation part, because one DC term or because of some constant term you might be getting. So I did not deriving it, just telling you the formula. Okay. So thank you for watching this session, guys. This is my Telegram group. Don't forget to join my Telegram group. And from tomorrow onwards, I will take the session on the app. Tomorrow, 5:30 p.m. on BYJU'S exam prep app. I will take the session on app now for next 3 days. I will not come on YouTube. I will take the session on the app. That is also free of cost. That is also same kind of question series. So you can join the question series in the app also. This is at 5:30. This is the Telegram group link. You can join this Telegram because I will be sharing the link of the session in this group. Okay. Thank you. The subject will be combined. All the subjects I will include because the next 3 days will be mock test for the multiple subjects, 4 to 5 subject tests together I will take. Okay, 4 to 5 subjects test together. Yes, kind of mini mock.